Hi guys, just let me know if I'm properly audible and visible and my screen is
Yes,
visible as well. Okay,
yes, ma'am.
okay. Let's just take one more minute and then we'll start the session. Okay, 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 great. So guys, today we are going to discuss some of the questions of engineering mathematics for GATE computer science. So in this session, we are going to solve some questions and the same type of questions you would find out in GATE test series, which is free for all the students. So you just type GFG GATE CS test series and you would get to the link. Okay, so let's start solving questions. I have collected some of the important previous year questions and as well as important questions and the same type of questions you would find out in test series. Just try to solve that by yourself because that is important for gate point of view. Okay, so this question says that we have a matrix A which has this vector 1 to 1 transpose and 1 1 0 transpose as eigenvectors, both with eigenvalue 7 and its trace is 2. Then you have to tell what is the determinant of A. Just tell me, guys, what would be the determinant of A here? And yeah, just let me know, guys. So we have a matrix A. If you would see, if we have a matrix A which has two eigenvectors, 1 comma 2 comma 1 and 1 1 0, right? As eigenvectors which has eigenvalue 7. So that means corresponding to this eigenvalue 7, we have this eigenvector and this eigenvector. And they are saying that trace of the matrix is 2. Trace is 2. Can you tell me what would be the determinant of A? Let me know, guys, in chat section. On YouTube as well. I can see on YouTube we have students joining. So I just want to know on Zoom section and on both YouTube. You would try this question by yourself. Just think about it and let me know. Okay, Supratik. What about other students? What all other students are getting? So we know that the determinant of a matrix A. Right, Supratik. So determinant of A, but is equals to product of eigenvalues. Product of eigenvalues. Product of eigenvalues. So you can see that we have given only one eigenvalue here, lambda. But this matrix is of order 3 cross 3. How I know that this matrix is of order 3 cross 3? Because it has a vector. It has a vector 3 cross 1, right? Eigenvector 3 cross 1. So this is a 3 cross 3 matrix. So that means I need here three eigenvalues. But I can see that corresponding to one eigenvalue, I am getting two eigenvectors here, right? So that means this lambda is repeating here. So I have two eigenvalues as 7 comma 7. But what about the third one, right? I have to find out the third one as well. So I know that sum of eigenvalues is equals to 2. So that means 7 plus my third eigenvalue, let's say lambda 3 equals to 2. So lambda 3 I got as 2 minus 14. That would give me minus 12. So now you can find out determinant. 7 into 7 into minus 12. So on solving, you would get it as minus 588, which is none of these option. None of the option matches to my answer, right? So here option D is correct. I hope all of you guys get it, that why option D is correct.
Ma'am, so the eigenvectors are of no use here.
Eigenvectors are of this use, that they are telling me that corresponding to eigenvalue 7, we are getting two eigenvectors. So these two eigenvectors are only here just to tell me that my eigenvalue is repeating. That means 7 comma 7. Nothing else. I do not have to use the values of eigenvector.
And the trace is the sum of eigenvalues.
Trace is sum of eigenvalues. Right.
Okay, ma'am.
Okay, anybody have any question? Okay, so if this question is clear, let's try to solve this question, guys. we have a matrix of order 3 cross 3. It has eigenvalues 1, 2, 3, and they're asking that for a scalar lambda, we can express this matrix P as this format. Then they're asking value of the scalar lambda will be. What would be the value of the scalar lambda? Just try this, guys. Anyone, guys? What would be the answer? So guys, you have to use here Cayley-Hamilton theorem. Okay, what Cayley-Hamilton theorem says that a matrix satisfies its characteristic polynomial, satisfies its characteristic equation, right? So now because I have given the eigenvalue, so can I form the characteristic equation? Characteristic equation would be x minus 2 into x minus 2 into x minus 3. So this would be characteristic equation of the matrix P. Right now I can solve this. On solving, what would I get? X square minus 3x plus 2 into x minus 3. And on solving, we'll get it as x cube minus 3x square plus 2x minus 3x square minus 9x, sorry, plus 9x and minus 6 equals to 0. On solving, we'll get 6x square 11x minus 6 equals to 0. We get this characteristic polynomial. Right? Now I can replace x with p because I know that a matrix satisfies its characteristic equation p cube minus 6p square plus 11p minus 6i equals to 0. Now I can convert this in this format. Let's take this 6i to the right hand side. It would become this. Now take 6 to the denominator and multiply left hand side and right hand side by p inverse. Right? What it would become? P square by 6 minus p plus 11 by 6 I equals to 6. Now on comparison, you can say that lambda is equals to 6. Right? And also, Lakshmi told me that you can put the value p equals to 1. Right? You can do that as well because we know that a matrix satisfies its characteristic equation. So that means every eigenvalue satisfies the Cayley-Hamilton like characteristic equation. So you can find out characteristic equation from here as well. This is matrix equation. You can find out characteristic equation from here as well and just put the value of x as well. Right? So you can do that. Just let me know, guys, if there is any confusion in this question. Everybody knows Cayley-Hamilton theorem?
Yes, ma'am.
Okay. Now let's try to solve next question. Okay, so this is simple question. Which one of the following provides the correct eigenvalue of the matrix? Simple question. You have to tell me the eigenvalues. Everyone? Right. This question is simple. We know that upper diagonal matrix or low upper triangular matrix, lower triangular matrix, or diagonal matrix has the eigenvalues which are on its diagonal. So on this we have on diagonal entries are 1, 4, 3. So the eigenvalues are 1, 4, comma 3. Right. So these will be my eigenvalues 1, 4, and 3. Right, simple question. Now, again, this question they have asked in GATE CS 2016. We have given two eigenvalues, and then now they are asking determinant of P. How would I find out determinant of P?
We have to multiply with the conjugate of that,
Right,
and
right, right, right.
then add.
Yeah. So basically, this is what is this? This is 2 plus iota. That means we have a complex root. And we know that complex roots always occurs in pairs. So if 2 plus iota is a root, then 2 minus iota is always a root of its characteristic equation. So now what would be the determinant? Now you would multiply all the eigenvalues. 2 plus I, 2 minus I into 3. On solving, you would get the eigenvalue. I think you determinant. So I think you would get 15 as your determinant. Right? Determinant will be 15. Now this question. In the given matrix, one of the eigenvalue is 1. Then they're asking what would be the corresponding eigenvalue, corresponding eigenvector, corresponding to the eigenvalue 1. Okay, so guys, Lakshmi is asking that why always complex roots occurs in pair. So what is complex root? Complex, if I have x square is equals to minus 1, right? What would happen? X would go, like the square root would go to the right hand side and we'll have plus minus minus 1. When would complex root occur? Complex root occur when we have square root of the negative term, right? Square root of the negative term, then we have a complex root. And if I'll take a square root of the negative term, so we'll always have plus and minus, right? Let's suppose if I have to solve x square equals to 1, x square equals to minus 1. Because of x square, we'll have x square. I'll take the square root to the right hand side and we'll have minus 1. So that means we'll have plus minus iota, right? So whenever we have a root a plus ib, we always have a root a minus ib, right? So then we have complex roots, imaginary roots. 2 plus root minus 1 can be written as two ways. Right. 2 plus square root of minus 1 would be 2 plus I. Right. This is one root. And because of I we have a root, then we have minus I as well as a root. 2 minus. Right, right, Lakshmi. Right. Okay, great. Now let's get back to this question. So this question says that given matrix, one of the eigenvalue is 1. Corresponding eigenvector you have to tell from the eigenvalue 1. Just try this question, guys. What would you do? So if you guys know the formula to solve the formula for a eigenvector is basically ax equals to lambda x, where lambda is my eigenvalue and x is my eigenvector. So here eigenvalue they have already given me 1, right? They have already given me this eigenvalue as 1. A into x equals to x. So I have to find out that particular vector with which I'll multiply the matrix A. It would give me x. So let's take any of the vectors. So alpha is a constant. There is no need to take it. I'll take 4 to 1. Let's say if I'll multiply this matrix with 4 to 1, do I get 4 to 1? If I get 4 to 1, so this is my eigenvector, otherwise not. So let's multiply these two. 4 minus 2 and plus 2 gives me 4. Then it would gives me 2. 4 ones are 4, 2 twos are 4, ones are 2. So it would give me 4 to 9, obviously. So this is not a eigenvector because when I'm multiplying A with the matrix X, I'm not getting X. Right now, let's check for B and tell me in chat section.
B must be the answer because C and D cannot be.
Okay. Okay, so everyone gets B as an answer. Do I need to solve it? Guys, do I need to solve it? I assume that I do not need to solve it. B is correct and C and D are incorrect option. Because what would happen? Because if you would take this matrix 1, 0, 1, minus 1, 1, 2, 2, 0, 1. If you would multiply this matrix with minus 4, 2, 1, you would get it as minus 4, 2, 1. And you are not getting for any another vector for the same thing. Right? So that's why option D is correct. Okay. Now, this is a question. We have given the eigenvalues and now they are asking for the determinant of A inverse transpose. Right. So basically, if I'll find out determinant of A, we know that determinant of A is product of eigenvalues, 1 into 2 into 4, that is 8. Now they're asking determinant of A inverse transpose. We know that determinant of A transpose is equals to A, so determinant of A inverse. And determinant of A inverse would be 1 by determinant of A, given that determinant should not be 0. So 1 by 8, that is 0.25. Not 0.25, sorry, 0.125. 0.125. Right? That would be the answer. Okay, so I hope this is clear. Right? Again, this is a simple question. Let's try to solve some more questions. Okay, no issues. So now we have a matrix A, UV transpose. Now they are saying that uh, the largest eigenvalue of A. We have given the vector U and V, and now they are asking the largest eigenvalue of A. Let's try to solve it. Let's try
Ma'am,
to
so the
solve
previous answer was 1 by 8.
1 by 8, right? 1 by 8, and because it is NAT type question, so it would you would put it as 0.125. Right? Now let's try to solve this one. Lakshmi, A would not be 1 cross 1 matrix. Just check it once. You would get a 2 cross 2 matrix. Just check it once. It would be a 2 cross 2 matrix, UV transpose. Okay, so basically the matrix A is given to me UV transpose. So that means U vector is 1, 2 and V vector is 1, 1. So if you would multiply these two vectors, you would get 1 with this row, 1, 1 and 2, 2. So this would be your matrix A. Now you can solve this using A minus lambda, right? That's how I find out eigenvalues now. You can solve it. 1 minus lambda, 1, 2, 2 minus lambda. Determinant is equals to 0. So I'll solve 1 minus lambda into 2 minus lambda minus 2. 2 minus 3 lambda plus lambda square minus 2. So lambda square minus 3 lambda, 2 and 2 get cancelled. So lambda eigenvalues would be 0 and 3. So you can take any one. Like you have to take the largest value, so that would be 3. वैभव इज आस्किंग मैम 16 घंटे पढ़ूं अभी से तो मार्क्स आ सकते हैं। देखो 16, देखो फीजिबल बातें करो, 16 आवर्स पढ़ना, मतलब अगर तुम लोग पढ़ सकते हो दैट इज अ डिफरेंट थिंग, बट 2 दिन पढ़ के एग्जॉस्ट हो जाओगे, तो जस्ट बी रियलिस्टिक विद योर सेल्फ एटलीस्ट, राइट? तो बी रियलिस्टिक, just give around, try to give 8 hours, 8 to 9 hours for your studies. Okay, so here largest eigenvalue is 3, right? Okay. Is there any question in this or any doubt? Now, let's try to solve this LU decomposition problem. So, guys, the topic LU decomposition is important. So, they have decomposed this matrix A into lower triangular and upper triangular. Now, they are asking that what would be the value of L3 or U5 or L2 or U6. So, you have to check all the values. Right, right, Ashish. Yeah, right. Just try to solve this. Don't you think the same, Ashish, that we are doing the questions for according to GATE exam?
How many options are correct here?
देखो विच ऑफ, देखो ऐसे ना लिखा नहीं आएगा कभी भी, इट वुड नॉट बी गिवन दैट इट इज MCQ MSQ, so you have to read the question what they are saying, which of the following questions are correct. So what they have used are, if there is a single option correct, they should have said which of the following is correct, right? So there would, this question is MSQ. So yeah, if there may be a possibility that it is MCQ or MSQ, they would say is slash R. Then you have to decide that it is MCQ or MSQ. But they have given here R, so that would mean that it is MSQ.
But actually, in the MCQs, we are not allowed to choose more than one option. If we click on another option after choosing one, then the original selection is deleted.
Okay, so yeah, that is right, right, right. So obviously, in this question, they are saying which of the following are correct. So now I know that it is MSQ, because every time in MCQ you do not check by clicking any another option that is it MCQ or MSQ. It would take so much time, right? So you can like understand the question language and then decide that it is MCQ or MSQ as well. Yeah, that is also a right option, that in MCQ we are not able to select two options, right? But yeah, but every time in in all the questions we do not try to click two options, na? So that's why you can like solve this, understand the question. Just tell me, guys. Okay, Pratik is asking, ma'am, can you explain SVD? That means, I think you are asking for singular value decomposition, Pratik. If you are preparing for GATE CS, in GATE CS, we do not have SVD topic, right? This topic is in GATE DA, but not in GATE CS Engineering Mathematics, right? So if you are preparing for GATE CS, you do not have to like take care of it, this particular topic. Okay, GATE DA. So yeah, like we'll have one session on this particular topic. Like, okay, Pratik is preparing for GATE DA. Okay, so this linear algebra session is happened on this channel. Like you can ask in linear algebra session because in this we are having session for GATE CS. So that's why I just don't want to confuse everyone. Okay, so yeah, no. Supratik, LU is in GATE CS. LU decomposition is in Gates, yes. Uh, Pratik is asking, another student is asking for SVD, that is singular value decomposition, that is not in ADA. So let me discuss this LU decomposition because Supratik is asking that he haven't read this topic, this concept. So basically, guys, where I just want to break this matrix A into lower triangular matrix and upper triangular matrix. And I have to break it such a way that their product L into U would become A. That means A matrix would be L into U, right? Now I just want to know that how I'm going to find out LU matrix, right? L matrix and U matrix. One way is that I'll multiply both the matrix and then check that, then compare the options. Then compare the options, right? Compare the left hand side and right hand side, but that would be lengthy, right? That would be lengthy. That means I'm saying that put L here 100, L1 10, and L2 L3 1, and just put this U matrix and then multiply and then compare with the given A matrix. But obviously this is lengthy and it would take so much time. We do not have that much time, right? So now I'll do, I'll use uh, row reduction, right? Everybody knows how to reduce the matrix A. So I'm going to do the same. So here L matrix is basically 1, 0, 0, 1, 0, and 1. I have to fill this value, or this value. Okay, so I'll do the same using row reduction. So I'll row reduce the matrix. Now to row reduce it, I have to subtract 3 from here and 2 from here with the help of this one. So what would I do? Guys, understand this point carefully, right? What I'm saying. To protect you as well, just let me know if you do not get any of the point. Now to row reduced, what is a row reduction matrix? I basically have to make 0, 0 here. And after this, I have to make 0 here. And yeah, that means I have to make these three zeros, right? Then it would become my row reduction, right? I'll do the same thing here. So R2 tends to R2 minus 3R1, right? That means with the help of R1, I'm making this value 0. Now, if I'll, and for to make this 0, what would I'll do? R3 tends to R3 minus 2R1. These 2 points are clear? Guys, these 2 points are clear? Okay. So now my row reduction, now you would row reduced it. So what would I left? 1 minus 1, 2. R2 minus 3R1. That would give me 0. Now I'll have to apply this on in the whole row. So R2 minus 1, minus minus plus, plus 3. Minus 1 plus 3, that would give me 2. And 7 minus 6, that would give me 1. Right? And then R3 minus 2R1, that would give me 0 here, minus 6 here, and 2 twos are 4. That means 1 here. Right? So I get this matrix. But now I have to fill these places as well simultaneously. Now you would see that what you have done with row 2. I have subtracted 3 from row 2. Right? I have subtracted 3 from row 2, so I'll add 3 here. I have subtracted 2 from row 3, so I'll add 2 here. Yes.
Ma'am, 0 minus to 1, the last row, or third row, I mean.
Sorry?
Ma'am, minus 4, minus of minus 2. I mean, it will be minus 2, na, ma'am.
This point, this one.
Third row, ma'am, third row. Yes, ma'am, minus
Third
6 will be minus 2.
Minus 6 would be, okay, sorry. It would be minus 2. Thanks. Thank you so much. Minus 4 plus 2. Right, right, right. It would be minus 2. Thank you. Okay. So guys, do you get it that how I place this value 3 and 2? Because I have subtracted 3 from the my matrix, row 2, I have added 3 here. 2 I have subtracted from this position, so I have added 2 here. Now the only thing happens to place one value here. So for that, I'll make this value 0. So with the help of this one, obviously, that's what we do in row deduction. So R3 tends to R3 plus R1, sorry, plus R2. R3 tends to R3 plus R2 because that would make this value 0. So I'll get 1 minus 1 to 0 to 1 and this would become 0, 0, 2. Right? Now you can see that because you have added 1 here with the help of R2. With the help of R2, I have added 1 here. So I'll replace it with minus 1. Now you can check that if this is your upper triangular matrix, this is your lower triangular matrix. If you would multiply, you would check by yourself. Just multiply L into you. Are you getting this A matrix or not? Just tell
Ma'am,
me,
how
guys.
did you replace it with minus 1?
Uh, sorry.
How
Just give me a
did you
minute.
replace it with minus 1?
Okay, guys, just give me a minute. I think my on YouTube, my camera is covering up this L matrix. So let me stop my video. Yeah. What are you asking? So what are you asking?
This yes, I'm asking how did you put that minus 1 in L?
Minus 1. Okay, so basically with the help of R2 at this particular position, I have used 1, right? I have added 1 in this row 3, right? Previously, what was I was doing? I was subtracting 3, so I have added 3. I have subtracted 2, so I have added 2. Now here I have added 1, right? So I have subtracted 1. I have added 1, so
But ma'am, you
now
have added 2 no? Then how did minus 2 become 0 then without adding 2?
no, no, with the help of R2, I have added 1, right? Because you would say, I just have here as well. You can see that we have R1. I have to only consider this minus 3. So with minus 3, I have replaced it with 3. With minus 2, I have replaced it with 2. But here as well, I have used R2. R2 is 2. That doesn't matter because I'm not changing here. My matter is what is the coefficient I have taken with R2, right? That is 1. So that's why I have replaced it with minus.
Okay.
Okay. So that's why. Now you can compare the options, which is giving me L3 minus 1, right? And U5 is 1. I think B is correct. And if I'll look for C, L2 is 2 and the U6 is 2. So C is also correct. So that means B and C are my correct options. Now, guys, let me know. I think on YouTube as well, everyone is able to see what is my L matrix. Right now, I think I can switch on my camera. Guys, let me know if there is any confusion. You can just let me know.
Ma'am, mean LU decomposition is nothing but we are dividing our like matrix into two matrices like upper triangular and lower triangular.
Upper triangular and lower triangular. Right, right, right.
Okay, ma'am. By reduction.
By row reduction. Basically, it's up to me how I have to reduce. I told you, na, I can multiply L with U. Let's say I'll multiply L and U, and I have the left-hand side matrix, then I can compare the values, left-hand side and right-hand side, and make equations. Then I'll get the values of L and U. But that would be very lengthy because we have so many variables,
हाँ
right?
ma'am,
I'll
I'm
get 9
confused.
equations to solve. So that's why I'm using here row reduction. You can use any of the option which you want. Okay, when it is 2 cross 2 matrix, I generally multiply two matrices. If it is a 3 cross 3 matrix, I use this row reduction. I hope the point is clear.
Yes, ma'am.
Okay. Now let's move to next question. So everyone gets it? If yes, then we'll move to next question. And if anybody have any question, you guys just let me know. Okay, so it says that a system of equations represented by ax equals to 0, where x is a column vector of unknown and A is a square matrix containing coefficient, has a known trivial solution when the matrix A is. Just tell me, guys, this question. So, guys, we have given homogeneous system of linear equation, right? Ax equals to 0. We all know that we have two types of system of linear equation, homogeneous and non-homogeneous. Ax equals to b is non-homogeneous, non-homogeneous, and ax equals to 0 is homogeneous. If you discuss, like if I'll take this ax equals to 0, we have two types of solution in this. Either we have infinitely many solution, infinitely many, or let's write down when either we have unique solution, or either we have infinitely many solution. So guys, see, when we have unique solution, if you would put x0 here, obviously 0 would always be a solution. So in case of unique solution, that means we have zero solution. This unique solution is zero solution. Sometimes we call this as trivial solution as well. Trivial solution as well, right? And when we have this trivial solution, when this like if x would be 0, then obviously a should be non-singular, right? A should be non-singular because a can go to the right hand side. What would happen if a is non-singular? Let's say a is non-singular, that means we can find out inverse of a matrix. If we are able to find out inverse of a matrix, so I can take x is equals to a inverse into 0, and then we'll get the 0 solution, a inverse multiplied by 0. So that means a inverse exists, or I can say that this case is non-singular. A matrix is non-singular. Or I can say that determinant of A is non-zero. Same thing, right? Now in infinitely many solution, everything gets reversed. We have non-trivial solution, but for this case, A cannot go to the right hand side. So that means A inverse does not exist. Does not exist. That means A is a singular matrix. Singular matrix. And we can say that determinant of A is 0, right? Now you can remember this chart. It would help you to solve all the question. So now they are asking for non-trivial solution. Non-trivial solution we have here. So in non-trivial solution, we have a singular matrix. So that's why option B is correct. Tell me guys if there is any question in this. Just remember this chart and you would be able to solve all the questions based on homogeneous. Let me tell you the chart for non-homogeneous as well. For non-homogeneous, we have unique solution, infinitely many solution. We have one more case in this. We have one more case that is no solution, right? We have no solution. And how we'll write down that we have a unique solution? That means rank of A augmented B matrix is equals to rank of A and equals to number of variables. Here we have only everything depends on A, but because of this B matrix here, because of this B is non-zero, we have dependency on A and B. And here we have rank of A augmented B is equals to rank of A, but it is less than number of variables. Right? And here we have rank of A augmented B is not equals to rank of A. Then we'll have no solution. Just tell me, guys, if anybody have any confusion in these two charts and this question as well. I hope this point is clear. The point is clear here. Let's try to solve the next question. Here, option B is correct. Everyone gets this. Okay, so this question, everybody knows which of the following is our eigenvectors of the matrix given below. We already have solved this type of question. So we have given this matrix A and they're asking that we have to find out that which of the eigenvectors. See, this question says that A slash R. So this can be MCQ or MSQ. So you have to solve it accordingly. So you can see that what are the definition of eigenvector? You have to solve Ax equals to lambda x. Now here lambda is not given, right? So any of you have to put x and see that if you are getting taking some constant out, you are getting your x original x or not. If not, then it is not an eigenvector, otherwise it's an eigenvector. Just tell me quickly in chat section, guys, which of them are eigenvector or not. See, Lakshmi, the question here says that A slash R because what we do, we check option A, then we go for option B. We get option B correct. Then we move to next question. That would be a mistake because it can be MSQ. So we have to solve this question completely. Otherwise, we'll lose marks in the in easy question. Okay, and we do not want to do that.
Ma'am, to find this, do we need to calculate the eigenvalues?
No, no, no. You do not need to calculate eigenvalues. Just take this vector. So basically, I told you the definition is Ax equals to lambda x. So what would I do? I'll multiply it with the first vector given to me, minus 1, 0, 2, 2. So let's multiply. If I'll multiply what you are getting, 9, 2 twos are 4, and 4 twos are 8. So what we are getting? Let's see, 9 and minus 4 and minus 8. That means we are getting minus 3. And if I'll solve this, 8 minus 6 and minus 2, that would give me 0. Minus 20, minus 20 plus 16 plus 10. So that would give me minus, that is giving me 6. Now let's solve for this one. Minus 32 plus 14 plus 24. 38 minus 32. That would give me 6. Now, if I'll take 3 common out of it, guys, see, have I done multiplication correct? Right? Have I done multiplication correct? Now you can see that it is not x, but they said that a into x. What I have done, I have multiplied a with the vector x. Now I just want it should be equals to lambda x. So if I'll take 3 common, it would give me minus 1, 0, 2, 2. So that means it gives me 3 into x. So that means a into x, I got as 3x. Ax equals to 3x. So that means option A is correct because we get one eigenvector x in such a way that I'm multiplying it with x, it is getting me, it is again giving me x, but with some multiple value, right? And it doesn't matter, lambda can be anything, right? So A is correct. Now let's check for B, C, D, all. Just check it, guys. Now it is clear.
B is not an answer actually.
No, no, no. I'm just telling the answer. Just try it by yourself. Tell me, guys, which of the option are correct? Nandini is asking AX values and lambda X values are different. No, ma'am. How it is correct? AX values are correct. X values and lambda X values are different. Just try to take something common. Like here, I have on the right hand side, I got minus 3066. I try to like because we have in my previous X, I have minus one. So I try to take three common, right? To make it minus one. When I have taken three common, I get my complete X, right? So you would know if you by taking something common out, you are getting your capital X. Just try to make it capital X by taking something common and all. Then you would get. Do you get it, guys? Just tell me if everyone gets the answer. What happens, guys? The concept is easy, but uh, like there might be a possibility that you would do problem in like solving calculation problem or silly mistake. There might be a chances for that, so just solve it carefully because the concept is easy. Okay, so guys, just try it by yourself. I have to cover more questions. So here you would find out that A, B, C are correct. Just check it by yourself, all the calculation. You would get A, B, C as correct options. Okay, now we have this another question. You have to find out the limit. So guys, from calculus part, we have two topics that are like that comes in exam. That is basically limit and definite integral. So just tell me what would be the answer here? What would be the limit value here? So basically, you would try to put x equals to minus 3 here. If you would try to put minus 3 here, So you would get minus 6 plus 22 minus 4 upon minus 3 plus 3. On solving, you would get 0 by 0 form. So whenever you would get 0 by 0 form, infinity by infinity form, then you can apply L'Hopital rule, right? L'Hopital rule. What L'Hopital rule says that just differentiate numerator and denominator together with respect to x. Yeah, Venkat, or we can rationalize. It's up to us. So basically, I just advise students to use L'Hopital rule because L'Hopital rule always works. Rationalization does not work in trigonometric or any another type of case. So that's why I always suggest students to remember L'Hopital rule. Okay. So now, if you would differentiate numerator and denominator, limit x approaches to 3. What is the differentiation of numerator? Square root 2x plus 22, right? That is a differentiation, and 2x differentiation would be 2 upon denominator is 2. Now, if you would put, you would get it as 1 by 4.25. If you would put the limit x equals to minus 3. Simple question, nothing else you have to do. You just have to like solve or differentiate numerator and denominator. Right? Is it clear? Then we move to next question. Okay. Next question is this again a limit problem. They're asking to find out the limit x approaches to 0, a to the power mx minus b to the power mx upon sine kx. You have to find out the limit value. Uh, Lakshmi is saying that in the previous question it was supposed to be root 2 upon root 2x plus 22. Why is it would be root 2? Actually, we have to use chain rule. Like if I have to differentiate this function square root 2x plus 22, so I'll write down this as 2x plus 22 to the power 1 by 2. First, I have to differentiate this power 1 by 2. So it would become 1 by 2, 2x plus 22 to the power minus 1 by 2. And then I have to go inside this function. Differentiation of 2x plus 22 would be 2. Right? So that's why this 2 and 2 get cancelled. We'll get 1 upon square root 2x plus 22. I hope differentiation is clear. Okay, great. Now let's solve this question. Simple question. Again, if you would put 0, you would get 0 by 0 form. Then you have to apply L'Hopital rule. So I assume that everyone gets the A option correct, right? Right. So this is a simple problem. Just try it by yourself. Right. Okay, let's try next question. Okay. Let's not solve limit question now. Let's solve. Okay, let's solve some probability question. Okay. Where's the probability question? Yeah. Okay. So the question here says that for a given biased coin, the probability that outcome of a toss is head is 0.4. The coin is tossed 1,000 times and x denote the random variable whose value is number of times that head appear in these 1,000 tosses. Then they're asking standard deviation of x. Tell me guys, what would be the answer? Think about it. So we have a biased coin for which we have a probability of getting a head is 0.4. And we are tossing that coin 1,000 times. And they're saying that x denote the random variable whose value is number of times head appear in these 1,000 tosses. Then they're asking standard deviation of x. Anyone has any idea how would we approach this question? Just tell me, guys, how I am going to approach this question. Okay, so yeah. Right, guys. So it is a binomial distribution because we are tossing a coin 1,000 times, right? So that means this is a binomial distribution 1,000, and the probability of a success we have given zero point 0.4, and now they're asking standard deviation. So the variance formula we have is NP into 1 minus P. So first I'll find out this variance. So 1,000 into zero point 0.4 into 1 minus zero point 0.6. So it would gives me 240, right? And standard deviation is basically square root of 240, right? So 15.49. So,
Ma'am, actually it should be 1 minus 0.4.
sorry, 1 minus 0.4. Right. Thank you. So it would give you zero point 0.6. Okay. So guys, you can see here that for each of the distribution, is it binomial, Bernoulli, exponential, Poisson, standard normal, or normal distribution. So you have to remember all variance, standard deviation, and its probability distribution. Just remember that, right? So that would help you to solve the questions. Okay, let's try to solve this question. Yeah, let's try to solve this question. Uh, Probability of A is given to me 1, probability of B is given to me 1 by 2, and then now they're asking probability A given B and probability B given A. Just try to solve it. Okay, some students are saying B, some students are saying D. Guys, try this question once. So if you would see probability of event A is 1, probability of event B is given to me 1 by 2. They're asking probability A given B. Can you write down this as probability A intersection B upon probability of B? So you have to find out A intersection B, right? So if I have to find out A intersection B, you can see that for a particular event, we have given the probability 1, and for another event, we have given probability B 1 by 2. And E is your main event. So you can see that if for a sample space, for a sample space, like if we are getting probability 1, so that means it is covering whole sample space, right? That means, so can I say that B is a subset of A? Can I say that B is a subset of A here? Guys, can I do that? No, Lakshmi. We cannot write down probability A intersect probability A into probability B because nowhere they have mentioned that A and B are independent events. Nowhere they have mentioned, right? But we know that because you can see that they have given particular event E, and now because they have said that they are asking for A intersection B, obviously it should be, if they are asking for a sample space, it should be particular one experiment, right? They're not different experiments. So if it is one experiment and they haven't talked about independence, so I cannot use that. So B is a subset of A. So can I say that probability A intersection B is probability of B? Right now, if I'll solve this, probability B upon probability B. So it would get cancelled, we'll get 1. Now, similarly, we can find out probability B given A. It would be probability B intersection A upon probability of A up equals to again probability of B upon probability of A. That means 1 by 2 upon 1. It would give me 1 by 2, right? So D option is correct, right? So I hope everyone gets it. Right, guys, option D is correct. So yeah, so these type of questions you can solve by going on GFG Gate CS test series. Just try this question once, and I suggest all of you solve as many questions as possible because I think now you have around 33 days left for your GATE exam. And if you would practice questions on, like, for particularly for maths, if you would practice question and revise the concept which you are not getting, then you would be able to get it. Okay, so yeah, all the best for your preparation. Just let me know, guys, if there is any question. Otherwise, we'll end the session. Thank you, guys. Thank you for joining, all of you.
Yeah.
And yeah, tell me.
Will you schedule any classes for revising the concepts?
Yeah, in January month, we are going to have our marathon session, which we'll take 3 hour session, but we do not make revision classes in that. We are going to practice questions for whole subject in one go. 2, 3 hours we are going to take that, or we are going to solve full mock test for your GATE exam.
Is it only for maths or for
No,
other
no, for
subjects
all the
also?
subjects, for all the subjects. For all the subjects we are going to do that. And yeah, if required, you can just let us know, like we'll try to have the, like, revision session as well, one or two, if
मैम बेस
that's
बेस थ्योरम
possible.
इम्पोर्टेंट है क्या मैम?
Sorry,
बेस थ्योरम इम्पोर्टेंट है हम लोग के लिए
base theorem, if we are talking about GATE CS, let me just remember, GATE D8 is very important, but let me just remember for it, for GATE DA. Yeah, base theorem is important because we have questions based on base theorem in GATE CS as well. They have asked questions,
यस
right?
यस
So just go once and revise it. If you do not get it, I have taken sessions on, like, previously. You can find out that and just go through.
उसमें भी तो मैम कंडीशनल प्रोबेबिलिटी भी यूज होता है ना बेस थ्योरम में?
Right. Right. So basically, it would help you to convert probability A given B into probability B given A. Okay, is there any another question, guys?
But ma'am, in other subjects, I'm getting some revision classes, like in TOC and digital logic, like in these subjects.
Okay.
For maths, there is no revision.
Like, I think there is previous year question session is going on. I just don't know. Let me ask with my team if it is required, then we are going to have revision session as well. But yeah, I assume that they are solving questions. Yeah, surely we'll have a revision class if it is, like, happening for other subjects. Let me ask with my team.
Okay.
Is there GFG playlist for calculus? Yeah, if you would go in playlist section, you would get GATE, like you would get whole mathematics course, right? Engineering mathematics. Let me tell you the name for that. Just a minute. We have one calculus series as well. Yeah, you can find out calculus as well. No, in this particular Geeks for Geeks Gate, if you would go, you would get the series for, you would get the playlist for probability, calculus, discrete mathematics, and linear algebra for all. You would get all the playlist there. So you would write down Geeks for Geeks Gate, you would get the channel. Okay, so yeah, that's all from my side, guys. Thank you for joining. All the best for your preparation.